Hey, ChatGPT o1 model now supports image uploads. I'm going to upload 10 challenging images to ChatGPT o1. Let's see what it says. So this is a Tamil magazine called Kuvudam, and my mother used to read it all the time. And my favorite part in this is called this section, which is called Spot the Difference or Spot the Six Differences. So what I'm going to do now is that I'm going to take a photo of this and I'm going to upload this to ChatGPT o1 and see if this can spot all the six differences that are right there. So these are the six differences here. So let's jump right in. So I'm already uploading this image to ChatGPT right here. And so I'm telling ChatGPT, this image has two similar photos. Can you find the six differences or the six differences in between? So in the meantime, what we will do is that I'll also we'll also see if we can spot the six differences. It usually takes me a couple of minutes or so. So for at least like few seconds, I'll let everyone see and see if they can spot the differences. If not, and hold the screen for some more time. Let's see what I think ChatGPT has come out with a response. So let's see what it says. So if I come back here, it says forehead mark of the fortune teller. So let's see if that in the top of the fortune teller's forehead decoration tilak or vibhuti differ. So let's see if that's true or not. So we come back and yes, that is true. So you see 3 here and you only see 2 here. So ChatGPT got the first one right. That is amazing. And let's go to the second one. So when you come to the second one, it says coins on the mat. The number or arrangement of the small white coins and pellets in front of the fortune teller on the pink mat is different. So let's see if that is true or not. So coins on the mat, 1, 2, 3, and this is like this, and this like this. I don't see any significant difference here, so I don't think this is true. So it got 1 right and 1 wrong. So let's go back and see what the next one is. So the next one is black object next to the magnifying glass. So let's see what the black object is. And yeah, so there's the magnifying glass here. So I think it's referring to this small thing here. So I think it got that one also. So it got the second one also right. And let's see what the next one is. Portraits inside the wooden box. The open chest behind the bird contains 2 portrait-like images. The features express slightly different from the top image to the bottom image. So let's see what that is. So we have the wooden box here, and so let's see. I see that this is what the actual difference is. You can see the red color here and the blue color here, but it also has portraits here. And honestly, I don't think the portraits are any different. Let me go back and check again if that's what it says. Inside the wooden box. Okay, the open chest contains 2 portrait-like images. The features or expressions of these portraits differ slightly from the top to bottom. So I don't think this is correct, although it was very close because these 2 portraits are almost the same, but the actual difference is inside the box. So I don't think that's the one it's talking about. So I think it got this wrong, but it was very close. And then background details. Hanging cloth says string. Okay, I think that is almost an easy one. So great, that is excellent. So if you see here, hanging cloth, this one is longer and this one is not. So it got that perfectly. Excellent. So, and then coming back, what else is there? Cage bars variation. So it says that the color pattern, number, or placement of cage bars or the objects inside the cage is not same. Okay, this is correct. So this is what we meant earlier by the like when you talk about what is inside here and what is inside here. So it got this one right too. That is amazing. So let's see how many it actually got right. So the first one is right. The second one is the second one is not right. The third one is right. Fourth one is not right. Fifth and sixth are right. So it got 1, 2, 3, 4. So it has got actually like 4 out of 6 correct. So it didn't get it didn't get all the 6, but so let's see what the other 2 6 are like. So one other, I've already seen this. It missed a very simple and easy one. Look at this one. This one is yellow and this one is red. That is like it just stares at you right away. And surprisingly, it missed that. It even got fine details like this one and the forehead mark and other things here, but something glaringly, which is right there, it missed that. So that is the fifth one it missed. And the sixth one it missed is actually very subtle, but if you actually see the mustache, there's no mustache here, so it missed that as well. So there are six. So just to kind of so these are the six things it actually missed. So if you see here, um, the one with the cloth and one, so this is what I was talking about. The yellow and orange were so obvious, but it missed that. And then the mustache also, it missed that. And so just to make it easier, what I've done is I've also marked these things here. So all the six ones are, there's one here, and there's one here, and then this is the most obvious one, and it's missed that. And then the forehead mark, and then also the mustache here, and also the cloth here. So what it did get right, it got this one, it got this one, it got this, it got the forehead marks right. So it missed these two things, but that's still good. It's good enough. I'm glad I was able to get this one. I wouldn't get like full marks, but 4 out of 6, it's still good enough for me. Great. This was a nice exercise. So this is a book, Linear Algebra and Its Applications by Professor Gilbert Strang from MIT. So I was lucky that I got this book, and I also got a signed copy of this book from Professor Gilbert Strang. So you can see that here, right here. And there's also another book. So this book is called Matrix Computations, and this is by the late Professor Jeannie Golub and Charles Vallone. And I was also lucky to get a signed copy of this book by the late Jeannie Golub. And so now, what we're going to see is that I was also lucky to get be snapped with both of them in two different occasions. Once when Professor Jeannie Golub was visiting India. This was in IIT Kharagpur. And this was my first journey outside of Chennai. So I'd taken a long train all the way to IIT Kharagpur, and to attend a conference during my undergrad days, and was lucky to get a photo with Jeannie Golub. And unfortunately, within a year, he passed away. And if you learned about SVD and matrix computations, he has done a lot of contributions towards that. And the other person, of course, is the famous Gilbert Strang. So I was also lucky to be snapped with Gilbert Strang when Professor Strang was giving a lecture at UC Santa Barbara, where I did my graduate studies. So what I'm going to do is that I'm going to upload both of these photos to ChatGPT 01. And let's see what it's able to say. And I'm going to probe it a little bit and then see what happens. So let me switch over. So I'm going to first ask something very basic. Okay, how many people do you see here, and what can you tell about them, and then things like that. So it's going to think for a while. So that was pretty fast. And let's see what it's actually trying to say. So it says. It says that 4 individuals in total. The image seems to be composed of 2 separate photos side by side. Excellent. Each photograph shows 2 people standing next to each other, making for 2 pairs of individuals. Left photo, there are 2 men. One appears younger, wearing sleeve and other one. The other one is older, wearing glasses, and so on. And then the setting could be indoor and academic. The right photo, the two men are again present. One younger and older. Younger person is wearing a casual T-shirt. And so on. So the backdrop appears to be indoors, and then so many other things, classroom or office environment. So it's just that overall, across the 2 photographs, there are 4 men in both pairs. Younger individual and older individual are standing together. Moment of mentorship or collaboration. The attire suggests academic, professional, or educational setting. There's no obvious signs that the 2 pairs in the separate photos are connected to each other beyond being placed side by side in this image. They may represent 2 different occasions in 2 different contexts. So that is correct to an extent, but again, these are big people in the world of linear algebra and matrix computation. So that is the connection that I wanted to draw. Excluding myself, but that's what I was wanting to draw from this whole thing. But it's kind of drawn up a general conclusion because it cannot. First, let me ask it and see. Can you identify any one of them? Anyone in the photo? I'm guessing it's usually these large language models are programmed not to identify anything. So yeah, it says I'm sorry, I can't help with that. It's like that was super fast. So let's probe it in a different way. So these are multimodal models, meaning that they can work with images, but they can also work with text, meaning that you can kind of pass in textual information as a text mode, and then try to see if it can do that. So I want to tell it, one of them is an MIT professor and author of linear algebra and its application. The other person was the author of matrix computation, but he's not alive anymore. So I'm giving the textual context here in a different way. So let's see if this context is able to like kind of guess who they are. So it's thinking for quite some time, but yeah, that's not too bad. So it's coming up right now with the answer. So let's just wait for it to complete. And so let's go. So it says that based on the clues you provided, an MIT professor of linear algebra, it is Professor Gilbert Strang. That is very nice. Okay. The author of the books, Matrix Computations, but he's not alive anymore. The best-known authors are Jeannie Golub and Charles Van Loan. Jeannie Golub, who passed away in 2007. Yes, that is correct. So was a pioneer figure, unfortunately though. But I sent him one email just before I joined UC Santa Barbara in 2007, saying that hey, we met and I'm going to join this university. He told me like congratulations, there are some great professors there, and that was the last message I had with him. And his work is a numerical analysis and numerical linear algebra, and it's widely recognized in the field. And I heard so many people say that SVD has a really strong relation to him. I've not gone and read the actual like papers or anything like that, but a lot of people, when they talk about him, they connected with SVD. So yes, it did show the textual context. To the textual context, it was able to guess that it's Gilbert Strang and Jeannie Golub. So from the photo, let me ask it. Can you say which from your knowledge, which ones are Strang? And I think it won't answer this, but let's see. I mean, it's just about trying, right? Yeah, so that's where these guardrails and other security things come out. So this is getting ChatGPT used to be a little bit more better than that, but it's getting more and more things. The jailbreaking is not going to be that easy. So let's see. I'm going to ask the other question. Can the younger person in these two photos be the same person? Can you compare the facial features? I'm sorry, and I cannot help with that. It's nothing else. That's it, right? Can you describe the facial features? Let's see if at least that it says. And if it could not even do that, light to gray hair of the, I should have said the younger person, but okay, the younger man, dark hair, similar in color intensity to the left on the photo, but potentially styled differently. And possibly a fuller face compared to the younger man on the left. So I should say that these were in two different years, right? One was in 2007 and the other one was probably 2011 or something like that. But still, interestingly, like I didn't get it. But that's nice. At least I'm glad to see that some things it's working. Like it did not recognize any one of them, and it's designed not to. So in that way, it's a success. And then when I gave the textual context, it was able to like kind of guess who they are. But at the end of the day, even though it's designed not to recognize people, it still didn't recognize them. So I'm not sure if I should give it what mark I should give this. So I'll probably just give this a pass, and see what maybe a 0.5 or something like that. So let's go for the next one. Hey, so the next one is person identification in surveillance and CCTV settings. So you can see two CCTV settings here taken at two different timestamps. And you can see that there is in camera 2, there is a person here, and then the same person is also there in camera 5. You can see some distinct features representing that two things. As a human, I can quickly say that these are two, the same person is appearing in different timestamps. So I'm going to upload this to ChatGPT 01, and then let's see what it says. So I'm just going to say that This is an image of two screenshots of CCTV multi-camera system with 8 cameras taken at different timestamps. So starting from the top left, name cameras as cam 1 to cam 8. So there's a person appearing in both left-hand timestamps. On which camera is the person appearing? Output a JSON with fields, person, timestamp, and camera number. So this is so that, like, if you want to use it in an application, you would need a JSON like kind of a thing, and then reflect on your own answer. So O1, I don't think it needs reflection, but there's nothing wrong in that. So let's see if it got anything right. It says 5 and 5, which I think is wrong, but let's see what it says. According to the prompt, we need to identify each camera in systematic order, stating on the top left. Okay, row 1, camera 1, camera 2, camera 3, row 2, cam 4. That it's all right. So it says that channel 1 is that is a good observation. The prompt states that there is a person appearing in both timestamps, the left-hand screen. On close observation, in the center camera of the second row, there is clearly, okay, it was able to find the person in the right one, because that is quite obvious. So this one, but even this one, there is a person. So let's see if I don't think it's able to find that one out. So yeah, it basically missed. So the clearest and most unambiguous present at both timestamps on CAN 5. Nope. In the left, it's I should maybe say in the left it's not, and it also says the dates and other things. So let me probe it in a little bit. In the left timestamp, the person is not in camp 5. Can you tell which camera the person is in? Let's see if this works. I mean, I'm looking for camera 2 as the answer. If it gets that, then that's really nice. So this is just one way of doing things, right? Like, one of the previous videos I showed how you can also have a people detection, a person detection using like models like grounding Dino, which if we just say person, was able to extract these two persons, and then it'll do the matching. So you can have hybrid systems which do these matching and kind of do this thing. But this used to be a very tough problem back in the day. Like my research lab at UC Santa Barbara used to be working in this person re-identification problem for quite some time. So let's see what it has says. Your request was flagged. Usage. The person is not. So I'm not sure what is what's wrong with the usage policy here. Can you try again? That was really funny. So funny or that is surprising, I would say, rather. So what I could do is I could maybe, let's see what it says. It's still thinking. I could rephrase the whole scenario to make it a simple problem. If this doesn't work, so let's just wait for a couple of moments and see. It's thinking for quite some time. Your request was finished thinking. That's it. So that's surprising. So let me do. I don't know if this will work, but let me do. This is limited to 2 screenshots. Let's start over. There's a person appearing in cam 2 in the left. Instead of that, what I'm going to say is that there's a person appearing in cam 5 in the right timestamp. Same person also appears in the left. So what I'm going to say is that, okay, you already found that it's the left one. Can you tell on which camera the person that's appearing in the left timestamp, right? So I'm just like kind of rephrasing the whole scenario so that it's more of giving some more context and information to it. So that's going to take some more time, but yeah, let's just wait for that. I mean, the applications of this could be lots of applications. Like if you want to track people across security settings, and then if you want to like send an alert and match the features and things like that. So many situations where this can be like useful, and you could have applications built on very simple applications, which previously used to take like quite some time. to and most of that analysis would have been manual. So all of this is like, if you have surveillance systems, AI and computer vision can have like a really good analytics and visualizations there. So coming back, it's still thinking, but let's see, it's here. Camera identification and timestamp. This is like, yeah, for 54 seconds it thought. So we have, it's doing a nice reasoning though. 8 cameras. This is okay. You said that the person is visible in campfire during the time. We need to find out on which camera the same person is in the left. Exactly. So it's basically broken down my question. It's kind of understood my question correctly. We previously attempted Camp 5 incorrect and Camp 2 incorrect. After carefully reviewing, the person who appears in the campfire on the right sampler is carefully in the Camp 8 on the left timestamp. Oh, that is not correct. That is completely off. Even if it had said it cannot find, I would have been okay. But it says that after carefully reviewing, it's actually like in the 8th Camp 8 in the left timestamp, and so it's going to give you 8 as the timestamp, which is a completely bad answer. So like, so if you go back, this is Cam 8, right? And I don't see any person here, and then so any careful reviewing is basically gone. So that's yeah, unfortunate, but in a sense, I mean, ChatGPT totally missed this. I tried to give a lot of context and then more things, so I totally missed it. So this one it's gonna get 0 as the mark. So let's maybe go to the next one and see. My next image is from a lecture by Professor Hani Farid from UC Berkeley. So he's explaining this lecture, but he's also kind of explaining a Python code on the way, and he's also explaining a concept. So what I'm going to do is that I'm going to send this screenshot to ChatGPT, and I'm going to ask it if, so this is a screenshot of a lecture by Professor Hani Farid from UC Berkeley. And can you extract the text, and also can you explain what concept he's teaching? So the thing is that this something like this is very useful to me, because I've seen Professor Hani Farid's lecture, and then since the text is embedded inside, it's kind of it's good to understand what he's teaching, but at the same time, I would be like, okay, what would be great if I can just copy the text and then do it. So let's see if it can first copy the text. So it says the first one is it's copied it very well, and then the one next is the model. So it's done that one also. It's extracted very well. And then it has the quadratic form, and then the steepest descent, and then while true, so it has this, and all of those things. So let's see if it's able to explain the concept. I mean, that's the interesting thing about O1, right? Like, it's not just a thing. So since the code is a demonstration of an iterative optimization method, that is correct. That is amazing. Now I finally am happy with O1. To solve a linear regression problem, here's what happening step by step. It is iterative optimization, so that is amazing. Like, so it says the code first generates a simple linear model, then YMC are shown. Random data points X, Y are created according to that line. Linear regression in matrix form, so it has like after defining X and Y, data is arranged in a matrix, and each row corresponds to a data point, and the columns indicate the X values. Okay, the goal of linear regression is to find parameters U that minimize the square. That is correct. In the predicted XQ and the observed Y, so that is also correct. So the quadratic, the least squares quadratic form is minimize the U such that XU minus Y the whole squared. For this, we derive A equals X transpose X and B equals X transpose Y. That is also correct. And the optimal view in a closed form solution is given by this. And let's see, this is the most important part, right? Which type of steepest descent, if it's able to get this. So instead of solving by a matrix inversion, that is amazing, because anybody, the basic thing in linear algebra, like Hilbert-Schrank's course, would be like you would do either a matrix inversion or you do the pseudo inverse. So it's great that it's actually able to go to this extent. Computing the residual Ri equals b minus AUI, which points in the direction of greatest decrease in error. That is correct. Determining a step size AI that optimally scales the update. That is also correct. And then updating uj equals ui plus airi. So in summary, Professor Farid is teaching how to solve a linear regression using a numerical optimization steepest descent rather than directly computing the closed form solution. This concept is a fundamental demonstration of gradient based optimization methods in machine learning and numerical analysis, and shows an iterative approach converges to the least squares approach. I am totally floored by this. This is what I would be expecting a reasoning model to do. So, and this is the and I've gone through these lectures, and Professor Farid is explaining that, and the interesting thing is that this would actually help me. I would want to kind of also like I would usually copy paste this and then do that, and then instead of I mean like copy, I will just literally copy them and be doing that. Now instead of this, if GPT can actually extract this text and also explain these concepts in such an amazing way, this is something what I was hoping for from Owen, and I think like out of all the answers I had so far, this one is the best and the one that am most happy with. So excellent, so happy. I'm going to give it. I should give it maybe even 2 points, but let me just stop it with one. My next photo is an interesting one. So I recently visited a Tata Chroma a digital store, and they had one really interesting thing at the entrance, wherein they said that don't dispose your e-waste, but like just like that, because it's harmful to the environment and things like that. So any electronic waste or e-waste, if we have and if you want to visit the Chroma store, we can just go to the Chroma store, and they were you can dispose of them there. In this way, they would take better care of it, and dispose it off properly. So it's a tricky question, and let's see. I think Owen should be able to get this, but let's try this anyway. So I'm just going to say, can you explain what you see in this photo? So what I'm expecting is to say that it's a place to kind of dispose of e-waste. So let's see. So the photo shows. So the photo shows a special e-waste disposal bin set up inside what appears to be a public area, possibly a store or a shopping complex. That is nice. So it is a store. It is the Tata Chroma store. At the top is a large poster featuring a prominent image of the Red Fort, Delhi, India. That is also correct. And then says Ministry of Tourism, Government of India, and the front says Incredible India. So these are like just ads and things to kind of buy Incredible India. So underneath this framed poster is a white and black collection box. On the box, printed in large letters, is the phrase "Dispose your e-waste here," and there are illustrated images of various electronic items, old TVs, refrigerators, and so many other things, meant to collect outdated or broken electronic devices. The presence of small patch of artificial green turf at the base could be a decorative element, so symbolizing environmental responsibility, possibly, yeah. So overall, the image represents a coordinated effort to encourage proper e-waste cycling and promote sustainable practices. This is exactly what I was looking for, and it got it right. So I am happy. So finally, like O1 is beginning to score, and supported both by a well-known retail brand, Chroma, Tata Enterprise, nice, and India's tourism ministry as well. So this is pretty cool. So I mean, this is exactly what I was looking for, and kind of it's able to like get that. So yeah. So my next photo is something which I come across practically. So this is a menu card from the restaurant called Bangalore Tiffin House, BTH. And I prefer Jain food. So Jain food is a specific type of food wherein it doesn't have onion, garlic, or potatoes and other things like that. And so the first thing I do in most restaurants is that I'll see if Jain option is available. So I'm going to give this to ChatGPT, and I'm going to ask it if it can identify like food which are Jain and also spicy. This is like practically like it kind of it's very useful to me and a lot more other people as well. So let's see. It's not. It's so basically the spicy ones are the ones which have the chilies in here, and the all the orange ones are Jane. So it has to actually think over and get these ones and these ones from the menu card. So I mean, as a human, you can quickly like find these out, pattern these out. Let's see if an AI model, especially ones like O1, is able to like get this and things like that. So let's see, and I think by looking at it, it's not doing the right job. I kind of expected this, but because it's like it's outputting quite a lot of things. Okay, based on the menu image provided, there are two symbols used for each dish: a swastika, which is like Jain-friendly food, and a chili pepper used to indicate the spicy. That is correct. So I'm glad it actually got that. So under the Bangarapet chart section, every listed item appears to have both Jain symbol and the chili symbol next to it. This suggests that all the items in that section are both Jain friendly and spicy. So this is amazing. This is the kind of reasoning I'm looking at. Let's go and verify if this is actually true or not. Because so let's see. Okay, that's where it missed it, right? So it said that under the Bangarpet chart section, so Bangarpet is like a famous area in Bangalore, if I remember correctly. It says so. What? So these are the ones which are spicy, right? Pani puri, Bangarpet pani puri, floating pani puri, and so on. And these are the ones which are Jain. So it caught most of the reasoning right, but what I'm actually expecting it is something which is both Jain and spicy. So these four and this one, right, and the fifth one. So think again. I want both. Let me say I want dishes which are both Jain and spicy, right? So so let's see if it's able to like just pick those ones. And so I really like the reasoning it's done so far, but unfortunately it's not getting both the things right below. Is a completed both. Okay, maybe I'm missing no, the menu list pani puri separately at different places, both with Jain and spicy. So maybe if there's a better way to like mention this, which are both Jain and spicy, instead of that I can say like I'm not able to think about it. At least as of now, I'm not. I think this is not what I expect from it. But maybe I need to improve my prompting also. But let's see. So I would give it like at least half a point because it's still the reasoning what it did was pretty good. So I still like that. But other than that, like it would have been great if it had given both those things. So let's go to the next one. So this one is going to be interesting. So this is what you call in South India, Tamil Nadu, and Karnataka, like pulikachal rice mix. And so what you do is that you mix it with rice and have it. So I'm going to ask ChatGPT, like O1, OpenAI O1, like what is this used for? And then how do you make a food out of it? Let's see what it says. So the jar contains pulikachal, also known as pulikachal, a concentrated tamarind-based seasoning paste, traditionally used as a flavor base to prepare the popular South Indian dish called puliodarai or tamarind rice. That is absolutely right. This is exactly what I was looking for. To use it, you typically mix a small amount of thick paste with freshly cooked, slightly cooled rice. The pulikachal imparts a tangy, spicy, and savory flavor, along with an aroma characteristic of South Indian cuisine. It often includes tamarind extract, chilies, sesame oil, mustard seeds, curry leaves, and sometimes peanuts or other spices. Once combined with rice, it transforms plain rice into a rich flavored meal commonly served in homes, festivals, and temples. This is absolutely amazing. It even got the fact that it's served in temples. Yes, it is very common in Vishnu temples in Tamil Nadu, like Puliyodara is like a very famous thing there. And this is what I was expecting. Imagine you're from North India or like outside of South India or even like outside of India, and you don't know what is Puliyodara, and you see this jar and then you don't know how to cook this, and ChatGPT O1 is able to, or OpenAI O1 is able to exactly not just say what it is, but also say how do you use it, how do you prepare it, just from looking at the bottle. So that is pretty cool. So something like this is what I was expecting. So I'm going to give this full marks for this one. So thanks. Yeah. So the next one is going to be really interesting. So this is a photo of of a calendar, and it has lots of events. And it's a religious event calendar, and then my dad uses this a lot. Like, so what he would usually do is that he would go and see, okay, what are all the events that are going to follow up in the next week and the next month, and so on, kind of thing. So what I'm going to do is that I'm going to pass this to ChatGPT, and I'm going to say that okay, today is December 7th. Is there any festival today? This is like the AI for daily use case scenario, right? Like there are so many things, mundane things we do in our day-to-day lives, and like AI could be used here. It's not like AI should be used here. AI could be used in creative ways, and to make our lives easy, and different ways. It's like whether you if you need it or not, kind of a scenario, kind of things like that. So what I'm doing is, and what I'm going to say is that, okay, today is December 7th. I'm going to ask it, if can you find any festival today. So it has to go through the whole list, and then it has to say. So it's put out a really large thing based on the common religious and cultural calendar. There are no widely observed major Hindu December 7th. It puts some well-known things. Additional Hindu calendar list either do not indicate any. Oops, it missed. So you see, this is very strange. It says ceremonies taking place on December 7th. The most notable events that month, such as Subramanya Sashti and Kalabhairav Ashtami, occur later in December. So that. Wait, I'll show you why this is funny. So on out of religious context, December 7th is International Civil Aviation Day. That's actually nice to know. And there are no, but it says that in summary, there are no significant traditional and religious events on December 7th. So now I'll say I like the answer, but it just missed one important thing. 07 December is Sri Subramanya Sashti. So this is what I wanted, right? And it says that, oh, there are other events in December like Subramanya Sashti and Kalabhaira Ashtami, but it's kinds of missed that. Think again, check again, and say and tell if there is any event on zero. So let me maybe say December 07 December. So I mean, it is actually like cheating. It's already missed it, but let's see if it's able to match this. I'm still impressed. It did give a lot of interesting stuff, but I was hoping it would have also like it almost got very close. So let's see if it's able to say anything now with the additional context. After carefully reviewing both widely recognized Hindu, it appears this does not coincide. It's again so many saying there's so many things. Calendar list various change this. How did it miss this, right? Like it says Kalabhaira Ashtami is on December 23rd, which is correct. Gita Jayanti December 9th, which is also correct, I think. And Dattadaya Jayanti is December 12th. And it says the 07 December, I also said the 07 December is Subramanya Sashti. Like it's like this Kanda Sashti equivalent in Karnataka and things like that. So unfortunately, it missed it. So let me even go further and ask Venus. So, this is like asking, it already missed, so no points, but let's see if it says anything. This is a funny parts in ChatGPT and O1. It's like it's almost got it, but it's somehow missing the last mile. So that's a very funny scenario. Subramanya Sashti is observed on the 6th on the waxing phase of the moon, the lunar phase, and okay, unfortunately, it's messing this up. So this is why it got it wrong. So basically, if you see, go back to the calendar. I'm going to share this tab instead. It's saying that so it's instead of 07, it's for some reason this has got it as 04. So unfortunately, that's what it is. What it is. So let me ask some other question. What all festivals are there after today? So let's see if it's able to get the other three festivals. So basically, like the Gita Jayanti, the Kali Kamba Temple Festival, and Kalabhaira Ashtami. So it says one more thing, which was, I think, in the previous answer, which is again wrong answer, I think. So let's see. Oops. And let's see where we are. So it says from December 8th, you have Sarah Gita Jayanti and a few other Jayanti and the Kalaprashtami and things like that. So it did not get this whole thing right. So unfortunately, yeah, even this one, some of it got it right, but the other things it did not get it right. So overall, I think this did not work out very well. It got close, but it was not able to do the thing. So let's get to the next one. So this one is actually a poster. My colleague Chandrakant had presented this work in ICPR a couple of days back, and so this is about controlled image, satellite image manipulation using like pre-trained models. So it's going to kind of, and it also has a forensics component towards the end. And this could be a great use of O1 and ChatGPT because this is like a complex image, right? So, and the thing is that we say you go to a conference and you see a lot of posters, you click, and it's difficult to absorb all the information. So let's see, and these are some real great use cases of AI or ChatGPT, which large language models, where you can actually quickly absorb information and put them in a nice format and things like that. So let's see if it's actually even able to get at this, like describe and explain this photo. I honestly don't know if it's going to, because this is it involves a lot of complexities, like images, block diagrams, text, and then so on. So, and that's pretty fast for that. Let's see if it's actually what it's saying. So this says so the image appears to be a research poster describing a system called SimGen. That is correct. A method for controlled satellite image manipulation using GANs. That is also correct. The overall theme is about making semantics maps, taking semantics maps, and generating realistic satellite imagery that matches those maps. That is absolutely correct. And by manipulating these maps, adding or removing objects or features, the authors can produce corresponding edits in satellite imagery in a controlled manner. That is correct. And then it mentions the author. So I was also fortunate to be part of this work. This was funded by the National Geospatial Intelligence Agency. And then you have so it describes the problem of context. That is pretty good. Then it says what is the method there, and then they also I think it's supposed to be mapped to sat, unless it's in the poster it says map to image. Yeah, so that is one small flaw I can find. It is not mapped to image, but it is mapped to sat, and it's trained on map to sat on these, and given a map it produces real images. So the pipeline shows the user should provided a manipulated semantic map, and then another user inputs a pristine map. In the trained model then generates a manipulated image. Yeah, that is correct. So results, then it also shows the visual results it's actually explaining. Then they also say what metrics it uses. This is all there in the poster, but it's actually kind of putting it in a nice way. And then that's really interesting. It's also got the image forensics part out of it. So what we had proposed was, we had mentioned how you can manipulate these maps, but then the second part of the paper was, okay, if you get manipulated images, we also proposed methods to kind of how can you train detectors which can detect these. So it was a two-faced paper. So yeah, it was able to see how what are the strategies that we used, like adversarial retraining and barrage of random transforms and so on. So summary, they have achieved visually realistic manipulation of satellite images. That is true, and they suggest improving replacing GANs with newer stable diffusion other models. Overall, it outlines a technique called controlled image editing of satellite imagery. By first altering a high-level map and then using a powerful image-to-image translation, they can produce natural-looking satellite images. Also underscores the importance of detecting such manipulation. That is amazing. I'm going to get a like. So yes, it's not just manipulation, but we also focus on the detection part. So it ensure. So it basically was able to absorb the full information completely just within a few seconds. imagine, like, you just, if you're a human to absorb this, it would take quite some time, and if you have it, if you do it in scale, if you have like hundreds of thousands of posters, it's going to take quite some time. Whether like as this was able to just do it just in a few seconds, so that is pretty amazing. Like, these are some tough but amazing, really nice use cases of large language models and AI, which could be really useful in many scenarios. So next time, yeah. Hey, so the next, this is going to be the last image for this test. This is a chart and a graph from one of my papers from back in my graduate school days, and so this is an interesting graph because it's a scatter plot which shows one side on the like how much percentage of matches for a particular like sample is for a particular experiment, and then it also has the like a sorted distance. So it's like if you have two scatter plots, this is a great way of kind of sort one and then represent the other. You'll find great correlations. So that's what instead of if you have two variables and then if you just plot them just using time as index, that may not give a great visualization. So these are some interesting analytics to know. So I want to, and this is from a paper called like back in the day. I have a paper called like co-authors called like Sarvam, Search and Retrieval of Malware. Today, like Sarvam AI in India is very famous, but yeah, long back, this has nothing to do with that. But a long back, had proposed a work called Sarvam, which is like a system for search and retrieval of malware, and it's actually even still active today. Like this system has this is a web server like which has about 7 million malware and benign samples in its database, and anybody can upload a sample and it's going to find the most similar samples from that whole large database or so. So it's been like almost 12 years, and it's great to see that we've received more than 500,000 submissions from world over from researchers and stuff like that. So this is where like this paper talks about the system design, the technical concepts, and then also like goes into the like even how do you do design experiments, the initial proof of concept experiments, and then things like that, and then talks about like whether it's actually working in the once you actually deployed the system. So what I'm going to do is, so this is a great nice chart is what I felt, because it's not just talking about one variable, but two variables are there, and you can find the correlations between them. So let's see what it says. So it says the chart is visualizing the relationship between a certain distance metric and the likelihood of achieving a correct score for 5,000 samples from the training step. Here is a step-by-step interpretation. That is really nice. So it actually breaks this down into steps. So what does the axis represent? Horizontal axis, index. Each of the 5,000 samples is represented along the x-axis. The samples have been arranged in ascending order of the distance value. That is correct. So you have the sorted distance. So that's a very important one, and kind of things like that. Left axis shows both sorted distance and percentage of correct match. That is absolutely right, because yes, it is there in the photo, but that's what is a key point here. A blue line represents a sorted distance for each sample, starting from the smallest left to the largest right. A scatter plot of red dots represents the percentage of correct match, corresponding to each sample's distance value. So then it says, what's the meaning? The distance is likely a measure of how far the predicted outcome is true. Yes, that is correct. And this could be something like a distance in feature space. That is also reconstructing. That is also right. Yeah, that's amazing. Then interpreting the curves, blue line sorted distance. So it says that starts very low on the left side, indicating many samples have low distance values. So as you move right, the distance increases. By the far right, you see the highest distance value. That is correct. So it's like some of the towards the left is like the ones which are very close to the database, very similar to samples in the database, and towards the far right are the ones which are far away from the database. So these are the ones which are for which if you have a database, these distances are very far off, right? So let's see overall trend. So now it's doing the trend analysis, and red dots. Okay, before that, red dots, percentage of correct match. For samples with low distance towards the left, the red dots are generally near the top. That is correct, meaning these samples have high probability of being correctly matched, often close to 100%. That is absolutely right. As you move towards with higher distances, these red dots spread downward, indicating lower values. So basically what it means is that when the distance is very low, you have some samples which are highly towards the left hand side. When the distance is high, you still have some samples which are also towards the right hand side. So let's see what further you are able to say. So overall trend is that when the computed distance between a sample and its expected representation is small, the system is likely correct in its matching classification. So yes, so for lower distances, it's going to give a great thing. You don't see that is very true. This makes intuitive sense. If a sample closely resembles what the model expects, it's likely to be correct. That is right. High distance is equal to low correct match. Conversely, when the distance is large, the sample is likely an outlier or poorly represented, so the model tends to be wrong more often. Highly distance usually signals uncertainty or incorrectness. So you can see that, right? Like there are a few high confidence and high distance and low confidence ones, and in the same way, for low distance, most of these are high correctness and very few in this area. So that's what you would normally expect. So implication for thresholding. So this is really amazing. I did not talk about thresholding in this graph. This is totally amazing because that's what I do next in the paper. I threshold based on this graph. This is the design graph, which is telling me that based on this design experiment study, do the thresholding, and it's actually so. Let's see. This chart suggests a natural threshold. If you set a distance cutoff, samples below the threshold will be on average be the correct match with high confidence, while samples above that threshold might be considered suspicious, deserving re-examination or conservative decision making. That is amazing. This is exactly what we tried to convey. We call this very high confidence match. High confidence we divided into 4: high confidence match, low confidence match, and then I think very low confidence. So the O1 is actually basically whatever I did as we did as a system and built this system. It's actually suggesting that, right? In short, the figure conveys the distance is a good predictor for correctness. Samples that are close to what the model expects are almost always matched correctly, while those that are far are much likely to be mismatched. That is absolutely right, and that is exactly what I wanted to convey. And not everything. So the thing is that not everything is mentioned in this text also, right? It's not just making things up just from the text. It's actually gone and kind of understood the exact more or less the exact implication of why we did that experiment and what that experiment could what the next steps of that experiment could be. If you're designing a system, these are the things which would be important. I would give this full marks for this to O1. It's just too good, and I'm so happy that I was able to get this one not just right but even exactly right. So